Hi guys. So in the previous video, we learned about what is order and degree of a differential equation. So before I work on anything else, I would first like you to revise on, if I give you a question, find out the order and degree of the given differential equation. Order and degree, of course, is a positive integer. That's first thing that you should know. Order is the highest order of derivative that is there in any differential equation. And what is degree? Degree is just like the concept of degree of a polynomial. So if your differential equation is like polynomial, so the power of the highest power of the highest order derivative that is included in your differential equation, that's what is degree. So if I give you a question wherein you have a differential equation which looks like this: 4 plus dy by dx square whole to the power 2 by 3 is equal to d2y upon dx square. So you have dy by dx and you have square of that. And then whole to the power 2 by 3 is also there. And then you have d2y upon dx square. So since we are playing around with power, so what I can say is that since you have the power 2 by 3 out here, I would rather want to, cube on both the sides so that I can get rid of the cube root, right? So what we can say here, we can just maybe cube on both the sides, and that would give us a better picture here. So you can just probably cube on both the sides, dy by dx square is equal to d2y upon dx square whole cube. So clearly, there's one thing that you can see here. The highest order of derivative that is included is d2y upon dx square. So clearly your order is 2. And now understand why is the degree 3. The degree is 3 because when you will cube, now you have a polynomial shape here. When you will cube, your d2y upon dx square is cubed, right? So the power of this, polynomial type of statement is the highest power of the highest order derivative is 3. So degree is 3. That is why you can see that I've written degree 3 out here. Okay. So next, if I give you another question here to understand whether you've understood degree and order or not. So square root of dy by dx minus 4 times dy by dx minus 8x equals to 0. Clearly, the highest order of derivative is dy by dx. So order is 1, no issues at all. Then what I can do is I can get rid of the square root. So for that, what I've done is I've taken, this to one side, okay, and kept a square root on one side. So then squaring on both the sides, I'll get 16 dy by dx whole square plus 16x square plus 64x dy by dx. So clearly what I can see is that the power of the highest order derivative dy by dx is 2. So 2 becomes your degree of this differential equation. So that's what is order, and that's what is degree of a differential equation. Now let's talk about what do we mean by solutions to any given differential equation. What do you mean by general solution? What do you mean by particular solution? So that's what this video is all about. Let's consider again an example. So let's consider a differential equation d2y upon dx square plus y equals to 0. This time the solution will be sum function. See, if suppose you have, x plus y equals to 6, then, you have infinitely many solutions, and, you will be giving values to some whatever, number. You will keep on giving values to x and y such that, the total turns out to be 6. But this time, what you're saying is that d2y upon dx square plus y equals to 0, which basically means, in some sense, what you are trying to say is that the double derivative, when you differentiate y with respect to x 2 times, you're getting minus times y. You're getting minus times y. So y has to be some function of x, okay, which is basically getting differentiated twice, and still you're getting minus times y, okay. So this time in differential equations, basically, it's not just the values, because you're dealing with derivatives in the equation, so y is essentially a function of x. And that is why, you're again talking about dy by dx, d square y by dx square, so on and so forth. Now, y is such a function of x so that when you substitute y, when you substitute y in the given equation, your left-hand side is equal to the right-hand side. And that means the equation is being satisfied, right? And that's what is a solution to any sort of equation. The equation needs to get satisfied. So left-hand side should be equal to the right-hand side, right? Now, so what's the case here? So I have a situation where d2y upon dx square plus y is equal to 0. Let's just consider. Right now, we're just trying to dig down that, what a solution essentially is. Then we'll get on to the methodology also. But now just imagine if this y was sine of, or a times sine of x plus b. I'm just involving a and b also here, so that you get a generalized form, okay? So suppose this function is a function of x, and mind you, why I'm talking about sine here is for a simple reason. When you differentiate sine, 2 times, when you will differentiate sine 1 time, you will get cos. When you will differentiate another time, that means you are differentiating cos. And when you differentiate cos, you get minus sine. And that's what you have in this situation. The double derivative is minus of the function that you have originally, y. So suppose y is a times sine of x plus b. Clearly, when you will differentiate this function once, you will get y dash. Y dash, as I told you in the previous lecture also, it's dy by dx. That would be a times cos x plus b. That would be a times cos x plus b, right? And when you will differentiate it again with respect to x, so you will have y double dash, and that would be, since the derivative of cos is minus of sine, so it will be minus a sine of x plus b. And with this, what do you realize out here? What do you realize out here is that if I will take the double derivative and add y to it, so basically, if I will take y double dash and then add y to it, I will get 0, right? Because I have a minus a sine x plus b plus a sine x plus b, and that cancels off, and you get, yes, indeed, it is equal to 0. So this gives you a general solution to this differential equation. Now, why general? Because a and b, I took 2 constants out here. They did not have a specific value. So that means I have taken a general function here. So it's a general solution, okay? In case a and b get some specific value, like say, when a is 2 and b is pi by 4, get the solution then. When a is 2 and b is pi by 4, your y will be equal to twice of sine of x plus pi by 4. Mind you, again, when you will differentiate, d2y upon dx square plus y will be still equal to 0. But now what do I have? I have particular values for a and b, the constants that I had before. So hence this is a particular solution. This time we have particular values. So this is a particular solution. But this time also your left-hand side is equal to right-hand side, which essentially means that it is a solution indeed, okay? So when function phi consists of arbitrary parameters or constants, a, b, then it's a general solution. When a and b have particular values, so when the function phi consists of particular values of a and b, that becomes a particular solution. That is it, okay? Examples. So, is y equal to e to the power minus 3x a solution of the equation d2y upon dx squared plus dy upon dx minus 6 times y equals to 0? Very easy to see. Why? Because this time I'm just asking you, I'm giving you a solution, not asking you whether this will satisfy this equation or not. It's very simple. So it's like, if you had a linear equation or a quadratic one, I'm just asking, I'm giving you a value. Okay. So suppose you had a quadratic equation, x squared plus 3x plus 6 equals to 0. And suddenly I just give you, okay, will x equal to 2 satisfy this equation? You will just put it back there in the equation and just check whether it is satisfying the equation or not. The same thing we will do with this differential equation also. Is e to the power minus 3x a solution of this equation? Let's check. So d2y upon dx squared is there. So I need to get the values of y dash and y double dash so that I can put it back. So y dash clearly is minus 3e to the power minus 3x. See, the derivative of ex is just exponential itself. But since you have minus 3 along with x, so of course chain rule will play its game. So you have minus 3 e to the power minus 3x. Y double dash becomes minus 3 into minus 3. So that gives you 9. So this is minus 3 e to the power minus 3x. This is 9 e to the power minus 3x. Now, the equation, y double dash, this is where it is, plus y dash. That means minus 3 e to the power minus 3x to be added. Minus 6y, that means minus 6 times e to the power minus 3x added. Okay, so now you can notice yourself, you have 9 here. If you will add up this, you will get minus 9 here. And of course, along with that, you have same thing, e to the power minus 3x. And yes, indeed, this is giving you 0. So indeed, this is giving us 0. Okay, so left-hand side indeed is equal to the right-hand side. And then that means yes. Yes. E to the power minus 3x is a solution. E to the power minus 3x is a solution, okay? Let's take another example to get clarity on this concept. So suppose this time y is equal to a cos x plus b sin x. Is it a solution to the differential equation d2y upon dx squared plus y equals to 0? Well, so that means what do I need? I need double derivative with respect to x. So I will first find out y dash. Y dash is minus a sin x plus b cos x. And then I would, of course, need y double dash, right? So this is your y dash and this is your y double dash. Can you notice something? This is your y. It's a cos x plus b sin x. And y double dash is minus a cos x minus b sin x. Clearly, if I will add the two, I will get 0, right? So hence, this equation will get satisfied. Clearly, you can, just with mental maths also, you can say that this equation is getting satisfied. And clearly, this is a general solution. It's a general solution to this equation. Why general? Because you have AB. AB, it's not taking any particular values as of now, right? What else can we have? In the next video, we will talk about formation of a differential equation whose general solution is given. Yes, if I give you a general solution, you can yourself also form a differential equation.